Hello friends, welcome to another video on making maths easy. Today I'm going to share some observations on squares and imperfect squares. I am Chinmay Kare and my mission is to help students like you build confidence in maths. I will be sharing different methods and techniques which will help you build conceptual clarity, and it will also help you with more accurate and faster calculations, which will reduce the number of errors you make. So let us begin with today's topic, which is squares and imperfect squares. So what's a perfect square? So a perfect square is a number which is obtained by multiplying another number by itself. For example, 4 is a perfect square, which is obtained by multiplying 2 with 2. An imperfect square is a number which is not obtained by multiplying another number by itself, right? For example, 5 or 6 or 7, right? They cannot be obtained by multiplying another same number with itself. So let's get started. So here I have listed the squares of 1 to 10, right? So what are the observations can you see? So if you look at the units digit of the results of squares, so you will see that 1 square is 1, so the units digit is 1. But there is some other number which also ends in 1, which is 9 square, which is 81. So we would list down as observation that the squares of numbers which are ending with 1 are obtained by multiplying numbers which either have 1 or 9 in their units place. Got it? Let's extend our observations. Let's look at another number. Let's look at the second row. We have 2 into 2, which is 4. Here we have 8 into 8, which is 64. Both end in 4. So our observation here is any number which is ending in either 2 or 8, its square must result in a number which ends in 4. So squares of number ending in 2 and 8 ends in 4. Similarly, let's look at the next row. We have 3 into 3, which is 9. We also have 7 into 7, which is 49. So extending the same logic, numbers which are ending in 3 or 7, the squares of such numbers must end with 9. Similarly, we have 4 square, which is 16, 6 square, which is 36, which means squares of numbers ending in either 4 or 6 must end in 6. The original number must also end in 5 for the square to be ending in 5. And finally, the squares of number which end in 0 must have 2 zeros in the end. So this is our first list of observations. So what did we see in this set of observations is that if we have figured out if we know the last digit of the number being squared, or we know the last digit of the square number, we can always figure out what the other unit digit is going to be. And we will see an application later in this session. Here's another list. I think you can also go ahead and confirm some of the other squares. You choose randomly and confirm the set of observations. As you can see in this small list that I've prepared, our observations that we have done so far are actually confirmed, where no, if you do 11 square, the result is 121. If again we do 99 square, the result is 9801. So basically our observation was that squares of numbers ending in 1 or 9 in the units placed, the square is always ending in 1. Similarly, 2 and 8, the numbers ending with 2 and 8, their squares result in 4. The numbers which end in either 3 or 7, their squares always end with 9. Numbers ending with 4 or 6, their squares end in 6. Numbers ending with 5, their squares end with 5. A number ending with 0, their squares end with 0. So this is our confirmation. I encourage you to try out some of the squares by yourself. and you can confirm some of these observations also. So let us look at some of the squares between 10 and 100. So I have listed 10 square, 20 square, 30 square, and so on up to 99. So what is the observations we can create out of these? So 10 is the smallest 2-digit number. Its square is 100, which is of 3 digits. 99 is the highest 2-digit number. Its square is 9801, which is a 4-digit number. So basically what is our observation here is that any 2-digit number when squared will result in either a 3-digit or a 4-digit number maximum, right? This is our second observation from the data that we have. And a final observation is this. If you actually look at the original list that we had prepared from 1 to 10, you will see that numbers 2, 3, 7, and 8 do not figure anywhere in the units place, which means that any number which is going to end in 2 or 3 or 7 or 8 is never going to be a perfect square. In fact, they are always imperfect squares. And that includes numbers which end in odd number of zeros, because if you square a number ending in 0, it always results in number of zeros which is even in numbers. So let's look at another example. So is 4578 or 9992 or 657 or 2953 square of a natural number? The answer is no. And why? Because we just created this observation and we realized that 2, 3, 7, and 8 never ever figure in the units placed of a perfect square number. So these must be imperfect square. So by mere observation of a number, you will be at least be able to tell if that number is a imperfect square or not. Now let us apply some of these observations to find the square. So here I'm not actually finding out the square of these numbers, but we are going to look at how to apply some of the observations we have made so far, which can help us arrive at the answer before we even start the calculations, right? So let us look at that. So we need to figure out what is the square of 26. So what is the first and second step? So look at the units digit of this number, which is 6. Square of 6 is 36, which means that now we know that the last digit of this answer that we want has to be 6, and it cannot be anything else. Also, we know that 26 falls between 20 and 30. Now 20 square is 400 and 30 square is 900. So therefore, 26 square must fall between 400 and 900, right? It has to. And the number of digits has to be 3, because on the lower side, we have 400, which has 3 digits. On the higher side, we have 900, which is also 3 digits. So 26 square must have 3 digits, and its last digit must be 6. So this is how we have applied our observations, and we have narrowed down our solution to some extent. In the following video, we will actually look at simple and quick methods of calculation of squares.